This brief is designed to help you understand the difference between rounding and truncating. These are things that we do when we have decimal numbers, or very large or very small, really any kind of number that's represented in its decimal format, and we would like to turn it into a slightly simpler, shorter, or easier to write number. First, let's look at rounding. The idea here is that we're going to move to the nearest easier number, and I've put easier in quotes there because what makes a number easier really depends on the context of the problem. So let's look at the number below, 3.536. That number is between 3 and 4. So if we wanted to round it to the nearest whole number, in this case we define the easiest number as a whole number, we would have to ask ourselves, is 3.536 closer to 3 or is it closer to 4? So to do this, we're going to look at the digit that's one decimal place to the right of the whole number. In this case, that means we're looking at the 5 that's in the tenths place. If this number is 5 or bigger, we round up. The number is closer, in this case then, to 4. So 3.536 would round to 4 if we're rounding to the nearest whole number. But maybe we want to be a little more precise than a whole number, but we don't need all of the decimals after the decimal point. So what if we ask, how do we round this to the nearest tenth? Is it closer to 3.5 or 3.6? It's clearly between those two numbers, but I want to know which one is it closer to. Again, we're going to look at the digit that is one decimal place to the right of the place we're rounding to. In this case, we're rounding to the nearest tenth, so we're going to look one digit to the right of the tenths place, and that's this 3 that's in the hundredths place. This number is less than 5, and so in this case we round down. 3.536 is closer to 3.5 than 3.6. And we can use this process with any place. We could use this to round something to the nearest 100 or to the nearest 1,000th. We can round to any place value that we want. Truncating is a slightly different process, and it means simply cutting off the digits past a certain place value. So we can take the same number, 3.536, and we can truncate it to the nearest whole number by simply lopping these 3 decimals off. We can truncate it to the nearest tenth by lopping the 3 and the 6 off. We can truncate it to the nearest hundredth by lopping simply the 6th off. Notice that we don't care whether we move it up or down, we simply chop off some decimals. Hey there! A reasonable question to ask is, who cares? Why is it that anyone would bother distinguishing between rounding and truncating? This seems like squibbling over the details. Well, let's look at a real-life situation where the difference between rounding and truncating adds up to real money. Suppose you and a friend go in together on a lottery ticket. You contribute $2 and your friend contributes $1. So you take that total $3 and you use it to buy a lottery ticket that then wins the $1 million jackpot. You decide to split your winnings based on how much you each put in. The question is, how much money should you get? So what you're really saying is, I paid $2 out of the $3 for the ticket, so I should get 2/3 of the $1 million. And your friend says, that sounds fair, so what's 2/3 of $1 million? Here's one way you could do this. You could turn 2/3 into a decimal first, and then use that decimal, the rounded version of it, to do your calculations. Here's what the math would look like. You enter 2 divided by 3 in your calculator, because you know 2/3 means 2 divided by 3. And the screen says 0.666666667. And you look at this number and say, this rounds to 0.7. I'm just going to take it out to one decimal place. Then you take 0.7 times $1 million, and that says to you that your share of the $1 million should be $700,000. So using option 1, you should get $700,000. Option 2 is you turn 2/3 into a decimal and truncate it. So again, you enter 2 divided by 3 into your calculator. The screen still says 0.666666667. And you decide, I'm just going to call this 0.6 because that's close enough. This is truncating, where you simply lop off all of the digits after the tenths place. So 0.6 times a million equals $600,000. Using option 2, your share of the winnings is $600,000. Notice that the difference between rounding and truncating changed your share of the winnings by $100,000. This seems like a pretty big deal. Option 3 requires that you not be a math wimp. You have to show some courage, and you have to actually deal with the fractions rather than reaching for your calculator the minute you see a fraction. Here's what the problem looks like if you are in fact courageous enough to deal with the fractions. You don't enter 2 divided by 3 into your calculator right at the start. Instead, you set up a problem that has fractions. You know that you want to find 2/3 of 1 million. And you know that in math, when you have that word of in there, that very often implies a multiplication problem. We want to take 2/3 times a million. And you know that when you're multiplying a fraction by a whole number, that it's helpful to rewrite the whole number as a rational number, to write 2/3 times a million over 1. You know that a million over 1 is just a million. You're rewriting the same number a different way. And you know that when you multiply fractions together, you multiply the numerators, so the top is 2 times a million, and place that over the product of the denominators, 3 times 1. When you do this multiplication, you get 2 million over 3. Now at this point, it is fair to reach for your calculator. And when you put this in your calculator, 2 million divided by 3, you get $666,666.67. Now notice at the end, we did still have to round that last digit because our calculator would have given us 0.666 repeating. The 6's go on forever. But by saving this step of putting it in the calculator until the end, the difference between rounding and truncating is a penny instead of $100,000. It is always best to deal with the fractions in the problem as fractions, because when you convert them into decimals, often you're forced to either round or truncate, and when you do that, you lose a great deal of precision.